perplexity. And then the entire basis of perplexity-based AI text detectors is that humans tend to write texts that have higher perplexity than a language model. So if you want to classify a document as human or AI, we just choose a threshold which best separates the two classes based on a data set of texts that we know to be AI or human. Then when it comes to actually choosing this threshold, we pick one that achieves a kind of error trade-off important for our setting. So in education, this means prioritizing having a low false positive rate, where here false positive is just defined as a document that's written by a human, but is predicted to be AI. So we want to keep false positives low because we want to avoid accusations of inauthentic work. So Perplexity has some major limitations. Documents like the US Constitution or popular books will have low perplexity since they're included in language model training data. So the contents and style of these documents is unsurprising to the model. And as a result, these documents get predicted as AI with high confidence, but for the totally wrong reason. And then another issue is that Perplexity just isn't robust to things like swapping words or typos. So in this example, italicized sentence, the original sentence has a low perplexity of 7. And then by adding these 2 characters that are highlighted in red, so introducing these typos, their perplexity reaches like a much higher value of 35, which could easily be on the opposite side of that prediction threshold we were talking about earlier. And then another family of approaches is based on something called text stylometry. So stylometry is just the statistical analysis of variations in style between one writer and another. And then in this case, we're interested in variations in style between human and AI text. So really, it's groups of writers. So this means defining some handcrafted features which we believe are more common in either human or AI text. And here we're looking at one such feature called the readability score. So the exact values don't really matter so much here, but the interpretation is that the higher the score, the more readable the text is. So you see that the score starts off high, is defined to start off at this magical value of 206. But then it's penalized by longer sentences. So long sentences tend to be harder to read, as well as long words. So if one assumes that LLMs tend to be verbose and use complex vocabulary, then this can be an effective feature that distinguishes AI from human text. Then there's a bunch of other features you can come up with. Let's say lack of syntactical and lexical diversity, repetitiveness of words, and also lack of coherence. You can then combine all of these features through some handcrafted formula or maybe some logic that's actually derived from data. So for example, if there's both repetitiveness of words and the syntactical diversity is low, then maybe we'll define a rule saying that kind of document is human, otherwise it's AI. And what's interesting to note is that earlier language models wrote quite poorly. So this is prior to the release of ChatGPT. So the logic here could actually get flipped entirely compared to a model like GPT-4o. So for example, now human text is probably more likely to lack coherence, let's say, than an AI-generated essay by GPT-4o, unless GPT-4o is explicitly instructed to be incoherent. And here's just like a clear visualization of what a model based on stylometry might look like. So once you define all of these features, kind of in these gray rectangles, we can use a decision tree to classify text as AI or human. So this is a toy example, but according to this model, if the text is coherent, but has spelling and grammar mistakes, chances are that it's human since AI tends to write without such mistakes. And then similarly, if the text is incoherent and doesn't use giveaway phrases like, ones we're very familiar with, like delve or in conclusion, then it might also be human. And then stylometric detection also has quite a few limitations. So prompting can be used to overcome obvious differences in things like readability or lexical diversity. Um, it also doesn't learn from more data. So you have this fixed set of rules that needs to be manually updated by humans somehow. And it's also not the most accurate approach. So there could be nuances in the text and long-range patterns that are just very difficult to capture with such rules. So those are some baseline AI text detection approaches. GPTZero, on the other hand, uses an entirely different approach. So rather than relying on some handcrafted features or relying on some language models to measure how surprising a text is, we learn from millions of AI and human documents. So we begin by gathering human texts that are guaranteed to be human based on a date cutoff, typically set to be prior to the release of major large language models. Then we'll generate AI texts corresponding to those human texts. We then clean this data so that it's free of any giveaways or formatting quirks. So an example of a giveaway would be an AI-generated text starting with a phrase like, certainly I can create an essay or create some assignment for you. And then lastly, we balance the data based on document type, such that it's reflective of what our users care about. So even though there's a bunch of computer code available on the web, we don't train on it since most of our users aren't interested in it, and it could also harm the impact of our detector on other categories. Then the secret sauce is in the model design. So at a high level, we use a neural network, similar in principle to um, large language models that power ChatGPT, but smaller in scale. And our model's objective is to distinguish between AI and human texts, um, rather than trying to predict the next word in a sequence. So at the end of the day, we end up with this model that outputs probabilities of a text being AI or human. And this concept of probability is actually a key concept in understanding detection results. The probability of an event in the classical sense is really just the number of times that event occurs divided by the total number of tries. So let's say we're interested in the probability of heads when tossing a coin. We can just repeatedly toss the coin and divide the number of heads observed by the total number of tosses. Um, the caveat here, though, is that for any sequence of tosses, it might not have this perfect, 50-50 proportion. But if there are infinitely many tosses, then a fair coin will exhibit this behavior. So obviously, in the real world, there's no such thing as infinitely many tosses, but you can use a large number of tosses as an approximation. Then in the context of AI detection, Probability can be interpreted as the proportion of neighboring documents that belong to a given class. So the illustration here shows that the user text in black is closest to 8 other human documents and 2 AI documents. And this just means that the probability of it being human is 80%. Then the more training data that there's access to, the more reliable this probability estimate becomes. And that's why we have such a big focus on training on vast amounts of data. Also, the concept of neighboring document here is learned by our model. So some models will cluster documents together, let's say if they discuss the same topic, and others will do so if the text has the same style. And here's an illustration of what our model ends up learning. So our model works by taking texts and creating so-called embeddings from them. And embeddings are just a numerical representation of the text that can be visualized in a plane. So initially on the left, the model knows nothing, so all the texts look kind of the same to it. But by the end of training, it starts to form clusters of embeddings, cleanly separating apart human, AI, and mixed texts. And we'll cover what mixed means shortly. So in practice, this separation is not so clean. So here's an actual visualization of the embeddings from our model. If you look closely, maybe see my mouse around this region, some of the red points, which are actual AI texts, are in the blue region, so surrounded by these human texts. Now, if you zoom in on this, we can see that the AI-generated texts, which are being misclassified as human, are actually quite similar to the nearby human texts in that they all have this distinct Wikipedia style. And typically with more training data, such an issue can be resolved. Now we're developing a tool which will have an interface similar to this, um, allowing you to visualize a document relative to our training documents. So let us know if you're interested in understanding the context behind our predictions by seeing the nearby documents that our model is basing its decisions on. Cool. So at a high level, GPTZero predicts several classes. So we have these 3 high-level outputs, either human, AI, or mixed. And this is now time for the fun part of the presentation where we'll go through some demos and actually explain what these categories mean. So a human document is just one that's primarily written by a human. This means that if you write something yourself, you use some spell check, that's okay. You could use things like Grammarly, that's also okay. Although if what you wrote is initially very poorly written and Grammarly ends up making like a lot of edits, then in some rare cases that might actually be classified as AI if you replace like 50% of your text with something that's suggested by an assisted writing tool. So I'm going to click into this example, and it's going to take us to the Wikipedia page of Warren Buffett, and we could copy some paragraphs here and paste it into our tool. You just paste it in, you click the scan button. Let's actually start with basic scan first. Second here. There we go. So you see On the right-hand side, we're saying that we are highly confident that this text is entirely human. Should be the case since it's copied, directly off of Wikipedia. We provide this probability breakdown. So we'll say, okay, we're 92% confident that this is purely human, maybe 8% confident that it's AI generated, and 0% confident that it's mixed. Like I said before, we'll get into what mixed means shortly. And then you can also see things like your most human sentences. I'll also explain what that means in a bit. We also have a feature called AI vocabulary, which will look for phrases that are overrepresented in AI-generated text. And in this case, there are none because this is a human document. So typically you won't see any here. Well, let's move on to some AI-generated examples. So awesome. So this is I was having some fun with this yesterday. Basically, I asked ChatGPT to come up with a conspiracy theory about One Flew Over the Cuckoo's Nest. And I think it did a pretty good job. It was quite convincing. But as you can see, you can probably tell just going through this, once you get to the final paragraph, it starts looking a bit suspicious. It has a very, very clear structure that's exhibited by AI. Let's copy and paste this text in. We'll go into basic scan. Great, and now we see that we're highly confident that this text is AI generated. The probability is quite high, so 98% AI generated. We get some highlighting for the most AI sentences. Let's also look at the AI vocabulary for this. Cool, so there's just some words that are present here, like aligns, for example. According to our analysis of all the data that we have access to, this phrase is 18 times more likely to appear in a AI-generated text rather than a human text. Also, the phrase crucial. Well, here's a similar sort of essay that I asked it to generate, but this time I made the prompt a bit more complex. So I explicitly instructed it to use vocabulary that a senior in high school would and told it to adopt a natural tone, essentially encouraging it to sound more human. Let's copy and paste this one and see if we're able to detect it. Cool, so this one works basically just as well. Instead of 98%, we're down to 97%, not a big deal. I'm not sure if the vocabulary has changed here. So in this case, I explicitly told it to avoid using phrases that LLMs tend to overuse, and it did so. So obviously, if you just come up with a detector that's based only on detecting these phrases, like maybe some of those stylometric features we were talking about earlier, it's not going to be very effective. But our model doesn't only look at that, it looks at a variety of different things. Cool. And within this category of AI, we're also able to detect if a text has been paraphrased / bypassed. So there's this entire market of AI detection bypassing tools that many people like to use to say, okay, I've generated an essay with ChatGPT the same way that I generated it here. I'll copy it into some bypassing tool. It'll tweak it for me with the aim of bypassing a detector. So let's try this out. Cool. So this right here is an AI generated text. Let's just verify that it's AI quickly. Well, so it is AI. So this one is like as high confidence as you could possibly predict. It's 100% AI generated. Now we can go to Quillbot's paraphrasing tool and paste it in and click the paraphrase button. This will just take a second, and you can see all the changes that it's making here on the right-hand side. We can copy this result. And let's see if this works. Awesome. So now you'll notice that in the result, not only are we saying that it's AI, but we're also saying that there's a possibility that an AI paraphrasing tool was used. So we're able to have that level of granularity even on AI bypassers. And we're we're regularly working to expand the set of bypassers that we can detect. Some of them work in fundamentally different ways, so it's really just a matter of time for us to adapt to them. Awesome. So now it's finally time to live up to that promise of defining what a mixed document is. So for now, our definition of a mixed document is either some interleaving of like purely human and purely AI text, or a continuation of human text with an AI generated prompt. So this example right here is actually taken from our website, and it's simply like 2 paragraphs. Let's see here. 2 paragraphs, the first of which is AI, the second of which is human. You see now that the highlighting is only being applied to this first paragraph, which is AI generated. And the result on the right-hand side is saying that this is a mix of AI and human. It's 87% likely to be mixed, maybe 13% AI generated. Notice that these percentages, they're probabilities. So it's not saying that 87% of the text is mixed. It's saying, no, this text is mixed, and we're making this prediction with this like 87% confidence. And then here's another example. So I took this, I believe this is like some Catcher in the Rye book report. And this excerpt here is human, and I just asked ChatGPT to complete the rest of the paragraph. So we'll copy in this first excerpt and copy in the completion as well. And we'll give it a scan. And again, you'll see that the highlighting quite accurately is able to delineate what's human and what's AI. And again, we're making this mixed prediction. So 4 out of 10 sentences are likely to be AI generated. Another thing that we're working on is expanding this mixed class to cover polishing. So if somebody, let's say they write an assignment themselves, and then they just copy that assignment into ChatGPT and ask it to polish it for them, we believe that that's still really their work. It's not like they're having, the AI do everything for them. So we don't want them to be penalized in the same way that, a fully AI generated text, you might be penalized for submitting that. So we're working on having a more granular classification of these kinds of texts so that, you as teachers have the ability to say, okay, maybe they use a little bit of AI help, and a couple of years from now, this will be considered as acceptable as just using a spell check. And that's okay, and we don't want to penalize them for that. So yeah, let us know if you're interested in this, because this is an active area of development for us. One other thing I want to mention here is our detector doesn't look at all text at once. Actually, even models like ChatGPT have this concept of a window length or a context length, meaning that they can only consider so much input at the same time due to compute limitations. So in this case, we might actually be looking at multiple windows and aggregating those results. And this is just like a toy example. So this is again taken from the Wikipedia page, but let's say for the sake of argument that the first paragraph is predicted to be human, and then the next two are predicted to be AI. We then aggregate those per window results and come up with a final prediction to say, okay, if it's a combination of like human and AI paragraphs, then we'll just call this mixed, even though we don't look at the entire text all at once. And then similar to this concept, for really long documents, these are actually handled by our Excel docs view, where we analyze documents on a page by page basis, basically. So I'll show you what that looks like here. So this is quite a long text that we have. So we pasted it in. Let's give it a scan. It might take a bit longer because the text is so long. Awesome. And now you see, instead of having this like, oh, we're highly confident that this text is AI or human, we now have per page results. So you can look at one page at a time and say, okay, is this page human or AI? Is this other page human or AI? And you go through all the pages. And these happen to all be human because I just copied and pasted this in from a pretty old book. So this becomes useful when you have like very long assignments, or maybe somebody's submitting their thesis, let's say. One other thing I'd like to note is the sentence highlighting you saw earlier. So when we were looking at those mixed documents and you saw, okay, we're highlighting just part of it, the AI part, and then we're leaving the human part alone. That's because GPTZero predicts sentence probabilities in addition to predicting these document level probabilities. So each sentence also has an AI probability assigned to it. And then this drives that highlighting. But one thing to note is that these sentence predictions depend on context. So if I take the same sentence and I copy and paste it into another document, it could have a different AI probability, therefore it could have different highlighting. And that's because the prediction at the sentence level it's not like being done in isolation. It's actually taking into consideration the entire document. And the last thing I'll discuss here is advanced scan. It's one of our most popular features outside of basic scan. And it gives you the ability to understand which sentences, are most important to a prediction. So the highlighting that you'll see here is reminiscent of basic scan, but it has a totally different interpretation. So instead of just saying that this sentence is AI, advanced scan highlighting says that this sentence is most responsible for the document being predicted as AI. So really, what that means is that if you were to tweak this particular sentence, this is the sentence that if you make some changes, you introduce like a bunch of typos, you replace a bunch of words, you totally paraphrase it, this would be the one that has the highest chance of making an impact on our overall prediction. But you'll notice that sometimes even if you do that, even if you edit those really important sentences, then our model will just look at another sentence. So it kind of has a fallback mechanism, and it doesn't just like rely on one or two sentences in a document. So here's just another AI-generated text. This time it's a blog post about an iPhone. Okay, so when we run basic scan, this is 100% AI generated, and you'll notice that the basic scan highlighting is entirely homogeneous. So it's just saying every sentence here is AI. But let's now see, to what extent each sentence is AI. So you'll see that some sentences are much more important than others. For example, this one is contributing to our AI prediction, as is this one over here, and also this one. And then the sentences highlighted in green are actually contributing to human prediction. So that can be a bit counterintuitive because we know that all of these sentences are actually AI. But what this scan is saying is behind the scenes, it's running a bunch of different analyses and saying, okay, if I were to include this sentence, basically if I were to like include it or remove it in combination with a bunch of different other inclusions and removals, what would be the probability that we predict? So we're looking at the sensitivity of our detector when we include or exclude a given sentence. And in some cases, that means even if a sentence is AI, it could actually be contributing to the human class when taken into consideration in this very holistic analysis of like, what would happen to my document if I included sentence 1, if I removed it, if I included it in combination with sentence 3, if I remove sentence 3 as well, that kind of thing. And I think this can be useful sometimes if you come across a document where, let's say, just a single sentence is highlighted very strongly for AI, and you play around and maybe you take that sentence out and that entirely flips a prediction, that could actually be indicative to you that our model is not so reliable on this document, and you shouldn't be taking our output as like ground truth. So basically take it with a grain of salt. So yeah, that's basically all I have for today. I'm going to open it up to Sean for Q&A.
Great. That's fantastic. Thank you. This is really a lot of information, and there's a ton of questions. So I'm going to do my best here to send some your way. There's been really great chat going on. Lots of people finding this information super useful. I think one of the early conversations that came up in chat and kind of in the Q&A was really around student intellectual property, what GPT-Zero is trained on, that sort of thing. Can you speak a little bit to that in terms of where the training data comes from and what happens to anything that gets uploaded to GPT-Zero?
Absolutely, yeah. So our training data is comprised of mainly text that you can, at least on the human side, text that you can find all across the internet, right? So this is the type of data that even large language models like, ChatGPT and whatnot have been trained on as well. So anything that has an acceptable license, we don't train on any, textbooks and stuff like that. It's just anything that has a commercially friendly license. And then we generate our own AI texts. As for what happens to student submissions, we don't train on that at all because it's part of our privacy policy, and also because we have no way of telling whether or not this is human or AI. Surely we can make that prediction, but we don't know at the end of the day, so it wouldn't even really be helpful to us.
Okay. And there was an early question too, and you may have answered this kind of along the way, but Um, how capable is GPT-0 of detecting generative AI that's not using ChatGPT, that never came from that particular LLM? I mean, I think maybe you already answered this, but I just wanted to throw that out there.
No, I didn't even get to that. So we can detect, we've made blog posts about this as well. We can detect outputs from models like Claude and Gemini and some Llama models as well, and DeepSeek too. We've noticed actually that DeepSeek, unlike Claude and Gemini, DeepSeek didn't really require us training on much data from it. So we suspect that its outputs seem very similar to like the ChatGPT family of models. So we do generalize, but we do prioritize these larger providers, um, just because those are the most, common ones, and I think that covers like the vast majority of what students would be using.
Yeah, that makes sense. That makes sense. And this is a really fascinating question that I never thought of. And a couple of people have asked a similar version of this question. But if the model is based on guaranteed human language from before the widespread availability of generative AI programs, how are you addressing the change in language that's happening out there? And similarly, will the proliferation of online AI generated text start to mess with training data?
Yeah, that's certainly an issue. So I think for that, we have a couple of options. Um, if we're really interested in gathering some of this post LLM human data, what we can do is convert this into a problem where we monitor the writing process itself. So through some kind of proctoring, we can guarantee that people are generating or are actually like writing these texts out themselves and saying, okay, well now this is what a blog post looks like in 2030 as opposed to 2010, for example, and we can capture these differences in slang and other phrases that become more popular over time. So we always do have that option, but I agree that, yeah, the web scale data is becoming problematic because so much of it is now just AI generated junk for the most part.
Yeah, yeah. Yeah, that's not something that I've really thought about, the fact that now there's a lot of AI generated text on the internet that's being used to train AI. I mean, it's a very strange situation. Yeah.
Also, you'll notice that, let's say you're using ChatGPT, it has the ability to crawl the web. Also, tools like Perplexity AI, a very famous now, sort of like a search engine alternative,
Yeah.
also crawls the web. But they will return results based on web pages that are actually like AI generated.
Oh, wow.
So I
Wow.
think it becomes important to have to add transparency to that, and that's also something we're interested in is through our Chrome extension and things like that, being able to show you, okay, if you perform a Google search or a Bing search, just giving you like an indicator of is this page AI generated or not, and that can affect how you interpret the results. Are you going to rely on this? If it's AI generated, who knows? Maybe the writing style is actually good, but we know that AI tends to have hallucinations, so you might not be willing to trust that content.
Right. Right. Yeah, exactly. Can GPT-0 identify the sources of AI generated data that it identifies? Like, can it actually see where it came from?
I see. No, not currently. This is not a very high priority for us, but we are also working on being able to say this comes from a certain uh, family of models. So we could do that, but yeah, I think beyond that, we're just interested in saying, is this AI or not? Yeah.
Right. Right. Yeah. I know that a lot of folks want to know, like, where students are getting the source, what materials coming from where, that sort of thing. So,
Oh, I see. Yes. So, yeah, in that case, actually, we have another tool. Um, I need to find a good document to show this, but basically, let me pull this up quickly in our dashboard. We have a tool called AI plagiarism. So if your document contains inline citations, as well as like a bibliography, we'll actually go and search for those references,
oh, wow.
and we can do like AI scans on them. And we'll also be able to say, does this source support your claim that you're making in your text?
Oh, wow. That would
That
actually
can
be really
be
useful
very,
That'd be really useful for students to use, actually.
It's useful for students and for teachers as well, because you don't know, like, okay, somebody writes an essay, they have like 10 references. Do you actually want to go through them all and be like, is this saying what you think it's saying? And
Yeah.
sometimes it's not even, uh, done with bad intention. Sometimes people generally misinterpret a source,
Okay.
and this, yeah, address that. So this
Yeah.
this is already live and available. I don't have a document right now to show you with.
Sure. Yeah. No, that's great. That's great. And I know that in future office hours, we're going to be talking about other tools that GPT-Zero offers as well. So hopefully we can touch on some of those another time. But a couple of questions have come up about sort of, and this is this could become sort of a market competition question, not to be at all. But I think there are a couple about sort of how confident are you that GPT-Zero can accurately identify AI generated text compared to other detection tools. Like, and I don't necessarily want to say, let's compare products, but can you talk a little bit about why you think GPT-Zero's detection is better than what they might find elsewhere on the market?
Sure. So I think one of the things is that the way that we tune our model outputs um, emphasizes like making few these false accusations of cheating. So basically, a few false positives. Other detectors on the web might be very sensitive, so they'll be able to detect more AI generated text, maybe some that we'll miss, but they'll also detect a lot more human ones as being AI, which is really like not ideal, I think, in this use case. So I think that's a primary thing. Again, other differentiators are just the scale and diversity of data that we train on, but I think other companies just have different priorities in terms of how sensitive they want their detectors to be.
That's great. Can a couple of questions came up about like using PowerPoint in GPT-Zero or other presentation um, platforms. Can it read slides and that sort of thing? That was just a question that came up a couple of times.
Um, A PowerPoint, I've not, I don't think I've ever tried to even upload one to our platform, so I'm not sure. If you were to paste in the text, then
Right.
potentially. But also, so one thing I should mention is that there is a minimum word count uh, under which you shouldn't really expect our detection or any AI detector's outputs to be accurate, just because there's not enough text. So if I give you like a 10-word sentence, you're not, how can you tell if that's AI or human generated? There's just not enough space for those patterns to emerge.
Right. Yeah, actually, there was a question about that from someone. She said that she would, when that happened with GPT-Zero, she would load the text in twice, like the same text twice to see if it would read it. Is that not a good practice? Is that not going to work?
I would say that that's not a good practice. Yeah, actually, some people, we actually sometimes do that ourselves just to bypass this limit.
Ah,
Uh, but that's not a good practice, because if you think about it, this goes back to that conversation of how large language models used to generate text. So they used to have this sort of failure mode of, okay, maybe they start generating a couple sentences and it's coherent, and then they totally repeat themselves.
mhm.
So
Right.
yeah, that's a not a good practice. Just try to get more text somehow.
Just try to get more text. Sounds good. There were also some questions, and I know this I'd be really interested to know your answer. And if it feels like there's not a really good answer, just say so. But there's a lot of questions about non-native speakers
Mhm.
who use AI to sort of improve their writing, make it more sort of standard English, and the concern is that those are going to get picked up as AI generated. What do you like? What happens with that in terms of GPT-Zero?
Yeah. So I think it's really tough because these models are not deterministic in the sense that one of these non-native speakers can copy in whatever assignment they're writing with the same instruction and get a different output back each time.
Right.
Sometimes the model will make a lot of edits, sometimes it won't make as many edits. So depending on that particular output that it's generated, maybe we'll detect it as AI if it's making like a lot of edits. Maybe it'll still be human if it's not making so many. But as I mentioned earlier, we're actually working on this very specific problem in terms of classifying texts that are like polished or just, rewrite this for me, polish this for me, classifying them as a separate type of class
Mm,
so that it doesn't have to be, black and white. This is human, this is AI. No, this is a totally different thing. And it's like a polishing. And we know that conceptually it has human origins, but just the output has been modified somehow.
right. Yeah, and I think that's just from a teaching perspective, from someone who taught for a very long time. I just want to sort of impress upon everybody, like these tools aren't really meant to just catch students out. They're really meant to create an opportunity to have a conversation with the students. So something like that, you have a foreign language speaker or second language speaker who may be using AI to improve their writing. That's a good opportunity to say, hey, this came up as AI. Talk to that student, say, did you use AI? Why did you use AI? That sort of thing. I mean, it really is an opportunity to build that conversation and that relationship, as opposed to just, a surveillance tool. I mean, we talked this was something that the webinar on Wednesday talked about as well. So yeah.
That's a great point, Sean. And this kind of use case, if they did write it themselves, they'll have that version available as well. And then you could just say, okay, here's what I did myself. Here's like the AI fixed version. Then you can have this conversation of like, okay, well, you actually, did all this work yourself. It's just making some tweaks for you.
Yeah. Yeah. Let me see other questions that came up. I mean, there's just so many. It's actually difficult to parse them out. We may have covered most of it, actually. Yeah, pretty much. There's a couple of pedagogical questions, and actually, I took down people's names. I'm going to email out a couple of folks. And if you have sort of more pedagogical questions about how to use the tool, feel free to just email me as well, and I'm happy to talk to you, teacher to teacher about some of that stuff. But and I apologize for anyone whose question has not been answered. I cannot tell you how many questions there are. Zoom just says there's 99 plus. So there's just so many questions. I can't get to all of them. But really, really appreciate everyone participating a lot. So there was a question too, and this may come to that sort of a polishing tool, which there was a lot of interest in, by the way, in the chat. A lot of students will use Ask AI to humanize their work. And I think there's actually tools out there that help students sort of like humanize what AI generates. So it's like AI doubled over. Do you have any suggestions around that in terms of how GPT-Zero might detect that? I mean, it sounds like it would still detect it, but I'm just curious if you have a response to that idea of humanizing AI text.
Yeah. So like I said, we're able to detect quite a few of these tools that are not just prompting ChatGPT to humanize an already AI generated text. Some of these tools work in very different ways. So some of them work at the sentence level. They'll just paraphrase sentence by sentence individually rather than paraphrasing the entire document.
Um,
Um, but I think, yeah, we're definitely, I think, capable of detecting this kind of very basic rewriting with a naive prompt, even very complex prompts. I showed one earlier where you're giving specific instructions to avoid certain phrases, to sound more natural and things like that. I think at the end of the day, um, yeah, it's tricky to get ChatGPT to not sound like ChatGPT.
yeah.
Even when you say, okay, write in this voice of this, famous person, it sounds almost like a caricature of that person.
Yeah, it totally does. Yeah, that's absolutely true. I've played around enough with it and tried to get it to talk in different ways to recognize that it still just sounds like GPT, like ChatGPT. Um, let's see. There was another question I just saw. Um, there's a lot of concern about students learning ways to bypass AI detection, obviously. And I'm not even sure if I understand this question, but I'm going to throw it at you just in case you do. Is re-encoding the text a way to bypass AI detection?
Green coding, I'm not, no, I don't know if I know what that means.
Okay, I don't either, unfortunately. So if there's a way, it's an anonymous person, but if you have a way of explaining that in the questions, that'd be great. Um, let's see. Um, oh, that's interesting. Okay, so I don't think this is necessarily a GPT-0 thing, but so all this discussion's been about the actual act of writing, but some people are using AI as a translation tool, so that if like a question comes at them in a foreign language, they use the AI to answer the question. Um, there's there's two questions, I guess, here. First of all, uh, do you have any comments on that? Like if someone was using that to translate the question and then answer it and the other question is another one that came up was what languages are supported by GPT-0?
Mhm. Um, so when you're doing this translation, I'm assuming that they're scanning that text in the translated language, so it's not English anymore. Yeah, that's also fine. So we support non-English for now, German, Portuguese, Spanish, and French. These are the
Okay,
languages we focus on. Yeah.
great. Okay, cool. And I did get an answer for that re-encoding thing. If the text is generated by AI
Yeah.
and then I write it again in Microsoft Word and then put it through the detector, will it still get picked up?
Yeah. Yeah, of course.
Yeah, okay, it will. And that's because the nature of the language itself, because I mean it won't detect that I didn't type it out, right? That I cut and pasted it because I would type it literally letter by letter.
Yes, so exactly. So we're not really relying on your typing patterns there. It's just like at this snapshot, here's the snapshot of the state of the text. Let's just look at that. We have been also thinking about tracking the writing process. Uh, this kind of goes back to proctoring a little bit more,
Hmm,
but I think we're still prioritizing more this sort of verification of like, here is the end product, because I think we need, in order for this other approach of doing proctoring, we need a lot of buy-in from stakeholders to be like, okay, this is now a platform where I should start writing my text, not just pasting in something I've already written.
right. Yeah. Which I think is a great idea. It would it helps people understand how the tool can be part of the writing process. And I think that's actually really useful. So okay, I'm going to go ahead and close this off here. So many questions. This was a great presentation, Alex. Thank you so much. And I know there's tons of questions, but the information that you provided was really, really, really helpful. I know. So as we close out, a couple of quick notes for everyone. First, when this webinar closes, you'll receive a very short survey to let us know how we did. And any kind of, if you can take just a couple minutes, those are literally 4 questions. If you can take just a couple of minutes to fill that out, your feedback is super helpful for us. And as a reminder, I know there were lots of questions about this, but as a reminder, I will be sharing out links to this recording of today's session, along with Wednesdays, along with all the slide decks. All of that will come to you by email on Monday. Our next webinar is going to be on May 28th, when we'll be talking about AI and media literacy with Weber State University's digital fluency resident expert, Stephanie Spiker. And that session will be a must-see for sure. Stephanie's a fantastic speaker. You'll have a great time. So thank you again for attending today's office hours. If you have any questions, please feel free to email me. I'm Sean, SEAN, at gptzero.me. And you can send me an email and we can check in then. So thank you again. I look forward to seeing you soon.
Bye, everyone. Thanks, John.